Today we're going to be working on absolute value equations and how to solve those. So remember, an absolute value is what we see in those two lines, and it's going to tell us how far a number is from zero. So the absolute value of 3, for example, is just 3 because 3 is 3 units away from 0. So if we had a number line, we have a 0 and we have 3, it is 3 units. That's the distance, and that's the absolute value. Similarly, if we have the absolute value of -3, well, that'll be over here, but absolute value is still telling us how far it is from 0, so it is always positive because distance is always positive. So absolute value will always be a positive number because it's telling us the distance of how far a number is from 0. So in this warm-up, we have if the absolute value of x equals 7, what are the possible values of x? So we're asked what numbers can we put in here for x that will give us a 7? Well, obviously, if we put a 7 in for x, the absolute value of 7 is 7. But also, if we put a -7 in for x, the absolute value of -7 is also 7. So the numbers would be either 7 or -7. Either one of those would work. On number 2, if we have the absolute value of x is -4, what could x be? Well, anytime we put a number in for this x, it's going to become positive. So if I put a 4 in for my absolute value, well, that's 4. If I put a -4 in, well, that's also 4. So we're never going to get a negative number from an absolute value because absolute value is measuring the distance. It will always be positive. So the answer for number 2 is that the possible values of x, there aren't any, because we will never get a negative answer with an absolute value. So let's now move on to how to solve these absolute value equations. We have 4 simple steps listed right here. Step number 1 is to isolate the absolute value expression. So what that means is that we're going to get the absolute value on one side, so we'll have something in the absolute value, and then on the other side we can have all of our numbers and stuff. But we have to have that absolute value all by itself first. Step 2 is kind of weird, but we're going to create 2 cases. So what we're going to do is kind of what we did in these first ones, where we're going to set what's inside that absolute value equal to both the positive and the negative value of the number on the opposite side. Because the absolute value, whatever's inside that, could either be positive or negative. Then we solve both of those, and then we finish by checking for extraneous solutions. Well, what does extraneous mean? I'm so glad you're asked. We're going to do a little definition here. So extraneous solutions are solutions that don't work when they're plugged back in. Mathematically, they might work, but when you actually plug them back in, they don't. So solutions that don't work when they're plugged into the original equation. Whoa, what happened there? When plugged in to the original equation. So it's like checking your work to make sure it works. And you would think, well, gosh, I did all the math right. Why wouldn't it work? Well, sometimes with this creating the 2 cases, it doesn't work out right. Let's work through a few examples. I think we'll work through about 5 or so. Okay, so number 3, we'll just work through together. We have our absolute value isolated. Notice that all that's over here is the absolute value, and then on the other side is our number. So it's isolated, so step 1, check. Now we're going to create our 2 cases. We take what's inside that absolute value, and we set it to both the positive of the value, and we also set it to the negative. So I set it equal to 5 because that was the positive, and I also set it equal to -5. And then we just solve. So I'll add 9 to both sides, and I'll get x is 14. And I add 9 to both sides over here, and I'll get x equals 4. So now I'm just going to do a quick check to make sure I don't have any extraneous. So I'm going to use that x value. I found 14, so I'm going to put that back in for the x. So I'll have the absolute value of 14 minus 9. Does that equal 5? Yes, it does, because 14 minus 9 is 5, and the absolute value of that is still 5. Now let's check the other one. So if I plug in a 4, if I do 4 minus 9 and take the absolute value, does that equal 5? Well, 4 minus 9 is -5, and the absolute value of -5 is 5. So yes, it does work. So I have two solutions, and I can just say that x equals both 4 and 14, and that's my solution. Okay, let's look at number 5. On number 5, notice our step 1 is not yet complete. I have this 17 over here, so my absolute value is not isolated. So I've got to isolate that first. So let's do that. We're going to move our 17 over so that all that's on this left-hand side is the absolute value. So that's going to give me y minus 1. And 23 minus 17 is 6. So now I'm on to step 2, where I create the two cases. So I'll have y minus 1 equals 6. And for my second case, I'll have y minus 1 equals -6. Now I'll solve both of those, and I'll get my two solutions. So I got -5 and 7. We'll just plug those back into the original. It's always good to go back to your very original just to make sure you haven't messed anything up. So I would have 7 minus 1, that's 6, and the absolute value of 6 is 6, plus 17. Does that equal 23? Yes, 6 plus 17 does equal 23. Then I have -5 minus 1. Let's see, that's -6, but I take the absolute value of -6, and that is +6. And we just discussed how 6 plus 17 is 23. So those are also both good solutions. So I have y equals, I always put the lowest one first, -5 and 7. That's considered good form. All right, let's look at number 7. We have 16 times the absolute value of r minus 5 equals -32. So once again, I don't have my absolute value isolated, so I need to do that, and I'll do that by dividing both sides by 16. So those cancel out, and now I have the absolute value of r minus 5, and that equals -2. And it says that we're going to create our two cases, but I want to stop right there. This says that it equals -2. Well, when we take an absolute value, we are never going to get a negative because absolute value is always positive. So if I have an absolute value that equals a negative number, that means there's no solution. There is no solving that one, because there aren't any solutions. It's never going to become negative. All right, let's go down to number 11. Okay, number 11, it looks like there could be a no solution, but I'm not going to jump to that. Oh, that's better. I'm not going to jump to that conclusion. So let's go ahead and get this one worked out. We're going to try to isolate that absolute value. All right, here we go. The first thing I'm going to move is going to be the -9 or -9. I'm going to subtract that from both sides, and that gives me -4 times the absolute value of c plus 10, and that's going to equal -24. Now I still don't have my absolute value isolated. So I've got to get rid of this negative 4. So I'll undo that by dividing both sides by negative 4. And that will give me absolute value of c plus 10. And that's going to equal 6. Because a negative divided by a negative is a positive. Okay, so I don't have that situation where it's an absolute value straight up equal to a negative. So this one should have some solutions. Let's see what they are. I'm now ready to create my two cases. I have c plus 10 will equal 6, or c plus 10 will equal negative 6. And let's solve those and see what we get. So over here, I get c equals negative 4, and I get c equals negative 16. All right, let's do a quick check here and make sure they work. So if I put, let me erase this so I can see it. Okay, I'm going to put a negative 4 in for my c. And I have a negative 4 here. That's going to give me a 6 on that. So that's going to be 9 minus 4 times 6. Does that equal negative 15? Well, 9 minus 24, yes, it does. And you're welcome to use your calculators on that. If I put a negative 16 in here, so that's going to be a negative 16 plus 10 is also a negative 6. So it's going to come out the same. So yes, those both work. And we have our solution is c equals negative 16 and negative 4. All right, let's just do one more. Let's go down to number 15. All right, so we do not have it isolated, so we have a little bit of work to do here. The first step is going to be move that 5n. So we'll move the 5n over. Okay, so I have absolute value of 8 minus 2n, and that's going to equal, that's going to give me 6n. 6n plus 2. Now I can set up my two cases. I have 8 minus 2n will equal 6n plus 2. Or I'll have 8 minus 2n equals, and I have to do a negative version of this. So that's going to be negative 6n plus 2. Okay, so make sure that's a negative, not just in front of the 6n, it has to be in front of the whole thing. All right, let's do the easy one first. We'll start over here on the left side. So I'm going to move my smaller n. So I'm going to move my 2n over here, which means I need to move my 2 over here. Okay, so that gives me 6 equals 8n. Oh, got some fractions, but that's okay. We don't mind fractions. So we have 6/8, which reduces to 3/4. So 3/4 equals n. Okay, and now on the other one, I need to distribute this minus sign. So I have 8 minus 2n, and it's going to give me negative 6n minus 2. So when you do both cases, if you have a binomial or a trinomial, you have more than one term, make sure you distribute that. It changes all the signs. So the 6n became negative and the 2 became negative as well. All right, so let's move those around now. So let's move the 6n again. And then I can move the, actually I did it opposite this time because my 6n is a smaller. I always move my smaller. So that's going to give me 4n equals negative 10. And when I divide, I'll get n equals negative 10/4, which reduces to negative 5/2. Okay, so I need to test these and see if they work. So I'm going to maybe use a calculator on this one. So now I'm going to put my solutions into my original equation. So I think the easiest way to do this is to use the store feature. So I'm going to start with my first one, which is 3/4. I'm going to do 3 divided by 4. And I'm going to store that as my x. So now every time I push x, it's going to put that in. And I'm going to put this in. So the absolute value on your calculator is under the number. It's under math, and then go over to number, absolute value. And I can put in 8 minus 2n, but I have an x, minus 5x. And I get that. And then if I do that on the other side, I get x plus 2, and I get the same thing. So that's a good answer. Let's do the same thing with negative 5 halves. I'm going to store that as x. And I can go back up and grab this so I don't have to type it all in again. And I get 25.5, and then I can go and grab the second one, and I get, negative 1/2. So that is not a good solution. See how those two do not equal each other? So when I plug it in, it didn't actually work. So this one is not a good solution, and I only have one solution, which is n equals 3/4. And the negative 5 halves is extraneous.